Hello guys, welcome to today's video. Today we're going to be talking about solving equations, more specifically solving equations using the balancing method. Now we're going to start by solving very simple equations. Now before we start solving equations, first I want to discuss a little bit what equations are. Okay, so let me give you a very simple example here. 5 equal to 5. In this scenario, this is a very simple numerical equation where you have a number equal to itself. It is an equation. You do have one side being equal to another side. Now, the way the balancing method works is by adding or subtracting or multiplying or dividing both sides of the equation so we keep it balanced. Okay? Now, why are we going to do that? The reason why you want to add, subtract, multiply, and divide to both sides of the equation is so that you can simplify the equation until you get to the unknown value. Now, in this case, we do not have an unknown value. In this case, I simply want you to see how the balancing method works, and it's quite simple. For example, if we want to add a value to this 5, let's say we add 10. All right, well, if we added 10 to this side would become 15. However, this side is still a 5. So to keep the equation balanced, we have to add 10 to this side as well. This would make this side 15 as well. So what we did here, we kept the two sides balanced. All right, now I can do the same thing with subtraction. If let's say I want to subtract 7 on this side, I have to subtract 7 on this side so that both sides can remain balanced. Okay, so 15 take away 7 will give me 8, and this side will also be 8. Now, you don't need to just add or subtract, you can also multiply both sides. So let's say I want to multiply this side by 2. Well, I have to multiply the other side by 2, so both sides remain balanced. Okay, here in this case, I'm going to get 16 equal to 16. All right, and we can move over here. Besides doing multiplication, we can also do division, as you probably can expect. Now for division, I'm going to write the number I'm dividing by underneath it. Let's say we're going to divide the 16s by 4. Now again, I have to do the same thing to both sides so that the equation remains balanced. So in this case, I'm going to get 4 equal to 4. Now, whenever you add a number to both sides, that move has a name. Okay, this is called the addition property of equality. When you subtract a number on both sides of the equation, that is known as the subtraction property of equality. Again, when you multiply two numbers on both sides of the equation, that's known as multiplication property of equality. And as you can expect, when you divide two numbers from both sides, that's known as division property of equality. And the whole idea is that whatever operation you do, you want to do the same operation with the same number to the other side, so both sides remain equal to each other. Now, why do we need to do this? Well, let me show you. All right, as I said, we're going to start with very simple equations. These are known as one-step equations. Okay, this is a single-step equation. So what I'm going to do is I'm going to do two examples side by side. On one side, I'm going to do a numerical equation, meaning you can see every number. So let's say we did something very simple like 2 plus 5 equal to 7. All right. Now, in this case, let's say we remove one of the numbers. Let's say we removed the 2. Let's say we did not know the 2. So I'm going to use x instead. So x plus 5 equal to 7. Now, of course, this is very simple. It's a very simple equation. You could easily guess what that x is. However, just so that we start using the balancing method, so that we understand how to use it properly, I'm going to show you this. Okay, so we want to find the x. Well, the problem with the x is that it has a number next to it. You're adding by 5. The goal is to eliminate everything that's near the x, so that you can figure out what the x is going to be when it's left alone. Now, here's how the balancing method works. you've got the 5 that's adding with a 2. Now the 2 here, it's technically our x over here. So to leave the 2 alone, what I can do is I can subtract both sides of the equation by 5. All right, now what that does is it eliminates the 5 that's adding and it transfers its opposite value to the other side. Okay, so underneath it, I'm going to go ahead and do the calculation. 7 take away 5 is 2. 5 take away 5 cancels, and that was the goal. The goal was to eliminate the 5 so that this number is left alone. Now, as you can see, by doing that, I know that this side will be 2 equal to 2. All right. Well, that works the same way if you did not know the 2. Because when you subtract 5, what we're doing is we are simplifying the equation until the x is left all alone on one side of the equation, leaving a numerical value on the other side of the equation. So here, 7 minus 5 will give us the 2. The 5 take away 5 cancels, leaving us the x all alone, which we can bring down on this side. Now, this equation is literally telling us that the value of x is 2 because x is equal to 2. So that's the answer. All right, now let's do one that we have to use addition on both sides. So this one we had to use subtraction because you had addition in the equation. One thing I did not mention is anytime you want to eliminate a term, you always need to do the opposite operation underneath it. Okay, so the additive inverse of addition is subtraction. All right, because of that, you can eliminate the 5, leaving the 2 alone, and getting the other value on the other side of the equation be equal to both sides. All right, so let's go ahead and let's do another example with subtraction. Now with subtraction, the number in front will be greater to make it easier for ourselves. So let's say we have 12 minus 4 equal to 8. This is our numerical equation where we can see everything. And on this side, let's say we are going to do x minus 4 equal to 8. Okay, now we know that the answer is 12, but just for the sake of seeing how the balancing method works, let's say we want to make this equation be equal to 12 because that's the unknown value for this equation. Well, to do that, you have to move over the 4, the minus 4, so that the 12 is left alone. To move over a number that's adding, a number that's subtracting, you gotta add it. All right, because the opposite will eliminate it. However, once you do something on one side of the equation, you have to do it to the other side. So I gotta add 4 on this side so that the equation stays balanced, as the name states. Okay, well, once we perform this, the 4 that's subtracting you can think of as a negative now, and the 4 that's adding, they're opposite, so they cancel. Bring down the equal sign, leaving you with 8 plus 4, which is 12, equal to, you bring down that 12, you can see that both sides are equal. Now for the numerical equation, we're not really solving for anything because we know everything. This is simply showing us how the balancing works. All right, now here we got to figure out the x. Well, to figure out the x, we got to move over the minus 4. To do that, I add 4, and whatever I do to one side, I have to do to the other side, so the equation remains balanced. Okay, here 8 plus 4 is going to give us 12. I'm going to bring down the equal sign exactly straight down where it was. The minus 4 and the plus 4 cancel because they are opposites, bringing down the x, leaving us with x equal to 12. And that's how we found the value of the unknown, the x. Okay, now let's try doing multiplication and then division. Okay, so let's erase this. By the way, all the equations that we're solving here are one-step equations. So let's go ahead and do a pretty simple one. Let's do 7 times 2 equal to 14. Right? Now for this one, I'm going to do 7 times x equals to 14. All right, now let's say, well, since I used x for the 2, let's say we want to eliminate everything and leave this equation be equal to 2. Now the way you do that is by asking yourself, what is the operation between these two numbers? That operation is multiplication. And what is the inverse operation of multiplication? The answer is division. Now when we use division in equations, what we do is we put it as a fraction underneath the number we want to divide. So we want to divide the 7 away. We're going to put a fraction bar under the 7. All right, now since these two both are multiplying, you can elongate the fraction line so it covers both numbers. So we're dividing this whole term by 7, and whatever you do to one side, you do to the other side. Okay? Now here, we're going to be doing the same thing. We're going to divide this term by 7. Now the reason why I'm covering not just the 7, but also the x, and not just the 7 here, but also the 2, is because I have multiplication. And multiplication combines two different separate parts into a single term. All right, in this case, the 7 times x is technically a coefficient 7 next to the variable x. All right, when I divide one side by 7, I got to divide the other side by 7 so that the equation stays equal. Now, what's going to happen here? Now, you could do it two ways. You can multiply the 7 by 2, getting 14, and then divide it by 7, getting back the 2. Or simply you can cross out the 7 that multiplies with the 7 that divides. Because 7 divided by 7 is 1 whole, and 1 times 2 is simply just 2. All right? Because these two canceled into 1 each. 1 over 1, which is 1, times 2 is just 2. And on the other side, 14 divided by 7 is also equal to 2. Same thing over here. Divide by 7. The 7 that multiplies cancels with the 7 that divides, leaving you with the x on this side equal to 14 divided by 7 equal to 2. All right. Now we can go to the last operation, and that is division. Now for division, let's see. Let's do 21 divided by 3 equal to, well, that's going to be 7. All right. And here, let's say the 21 is missing, x over 3 equal to 7. All right, we want to find the x. Well, again, we ask ourselves, what is the operation? So since I chose the 21 to be the x, we want to focus on the 21 on the numerical equation, meaning you want to make this equation, both sides of the equation, be 21. To do that, what I have to do is I have to get rid of the 3 here. Now the 3 is dividing the 21, so division can be cancelled by multiplication. Now, I'm not going to write times 3 underneath the 3. What I'm going to do is I'm going to write times 3 on the side here. And whatever you do to one side, you do to the other side, so the equation remains balanced. All right. Now I'm going to do the same thing for the algebraic equation here. I'm going to multiply both sides by 3. Okay. Now in the numerical side, what is happening is that this 3, you can do it two ways. You can multiply the 3 with the 21, but then you have to divide it by the 3 here. Okay. Or you can simply cross out the 3 that multiplies with the 3 that's dividing, because in the end they're gonna cancel out into a 1 whole. So you're left with just the 21 alone, equal to, and 7 times 3 is 21. on this equation, same thing happens. The 3 that's multiplying cancels with the 3 that's dividing, so you can cross them out, leaving you with the x here equal to, well, 7 times 3 is going to give us the 21. Now the numerical equation mainly shows that you can make two sides be equal to each other by removing things that are near the number you want to keep the equation equal to, in this case the 21. Whereas the algebraic equation wants you to find something that's missing, in this case the variable x, and we use the process of eliminating terms in order to leave the variable alone. And the way you do that is by using the balancing method. Whatever you do to one side of an equation, you do to the other side. So you can do all 4 operations. Whenever you do addition to both sides, that's known as the addition property of equality. When you use subtraction on both sides of the equation, that's the subtraction property of equality. Multiplication is the multiplication property of equality, and division is the division property of equality. All right, so let's move on to something that's a little bit more complex. Now, I'm not going to keep on using a numerical equation here because I think at one point they become more distracting and confusing than helpful. So here I'm going to go with a pure algebraic equation. Now, this one is going to be a 2-step equation. And the reason why they are called 2-step equations is because they have 2 operations in them. So let's say we have the equation 2x plus 5 equal to, now let's go ahead and make this 11. All right. Now, I've already thought of the value of x. However, we got to solve using the balancing method. The way you do that is by eliminating the 2 and the 5 so that the x is left alone. Now the question is, which one should I eliminate first? Should I eliminate the 2 or should I eliminate the 5? The answer is you want to first eliminate the 5, and here's why. The 5 here is known as a constant, aka a number that's by itself. The 11 is also a constant, a number by itself, which means that if I do the opposite operation, the inverse operation of addition, I will cancel the 5 from this side, I would move it over to the other side and be able to combine it with the 11, leaving the 2x alone. Now, if you try to cancel the 2, you would have to divide. Now, you could do that. However, in division, you are not supposed to just divide one term on one side and one term on the other side of the equation. Division and multiplication affects every single term. So if I divide by 2 the 2x, I got to divide by 2 the 5, and I got to divide by 2 the 11. And as you probably can tell, 5 is not divisible by 2, at least not as a whole number. And 11, same thing, you would get a decimal. So to avoid problems, what you do first is you try and combine like terms. Now, like terms, when they're on opposite sides of an equation, you're not supposed to just add them or subtract them. You have to do the opposite operation. The inverse operation of addition would be subtraction. So here we're going to use the subtraction property of equality by subtracting the 5 from both sides. Eliminating the 5 on this side. And on this side, we get the difference of 11 and 5, which is the 6, equal. Now the 5s went away, so I simply bring down the 2x here. And that's not the final answer because the 2 is next to the variable x. Now the 2 is a coefficient of x. And if you guys have seen my other videos, the coefficient is multiplying the variables. You can put a little dot there to remind yourself that these two are multiplying. Well, what is the opposite operation of multiplication? The answer is division. So if you want to get rid of that 2, all we got to do is simply divide this whole term by 2. Whatever you do to one side of the equation, you have to do to the other side. So we got to divide this side by 2 as well. On this side, the 2 that's the numerator and the 2 that's the denominator cancel into one whole. 2 over 2 is a 1. So on the bottom here, I can write it as 1 times x. But what is 1 times x though? It's simply just x. So I don't need to put the 1 here. I just simply write the answer as x equal to 6 divided by 2 is going to give us a 3. And that's the final answer. So what are we doing here? Well, we are using the balancing method to simplify an equation until you make it so simple that you leave the variable alone on one side, leaving you with the answer, the numerical answer of that variable on the other side. So this is it for this video. In the next video, I'm going to show you guys how to solve multi-step equations using the balancing method. All right, if you enjoyed this video, please make sure to like and subscribe. Make sure to also comment with any suggestions or any ideas that I can use to improve the video and make new videos. Thank you so much and have a good day.